Hi, welcome to the Michigan Science Standards Administration Awareness Professional Development. My name is Wendy Vogel. I'm the Science Consultant at the Kent ISD, and I'm going to walk you through about a half an hour of information on the new Michigan Science Standards. There will be a set of resources below this particular video that you can access anytime, and the bit.ly in the front of this video, Admin Awareness, will take you to the actual slides themselves, and all the links are active within those slides. So let's begin by talking a little bit about the standards themselves. As with any new set of standards, there's a new language that we need to learn. The Michigan Science Standards has a set of jargon that is typically made up of acronyms. So let's go through those acronyms a minute. A PE is a performance expectation. This is another term for the word standard. We're very familiar with those here in Michigan, and of course we need to be reminded that it is what the student should be able to accomplish at the end of a unit or lesson. The DCI is considered the disciplinary core idea. This is the science content. The CCCs are the cross-cutting concepts. These are the overarching science ideas that typically cross over both science discipline as well as cross-curricularly. Examples of these might be energy and matter, stability and change, or cause and effect. The SEPs, or science and engineering practices, are the doing of science. We want students to be analyzing data, or asking questions, or defining problems, things that scientists and engineers do in real life. Together, the DCI, CCCs, and SEPs make up what's called the 3 dimensions of learning, or 3D learning. That means all 3 of those parts, DCI, CCC, and SEP, are considered part of the standard. So a student must be proficient in all 3 in order to truly master a standard. The frameworks is another component that you will want to be familiar with. This is the research or backbone of the new science standards. The full book or publication is called A Framework for K-12 Science Education and can be downloaded at the National Academies of Press, and it is free. Please understand that it is a 495-page document, so you may not want to print it. Topic view is the way that the state of Michigan has chose to adopt the standards. It's really pretty much by discipline. Okay, when you look at the 3 dimensions within the standards, there are the science and engineering practices, disciplinary core ideas, and cross-cutting concepts. As an educator, when you look at the actual performance expectations, you will see color-coded foundation boxes underneath them. The science and engineering practices are in blue, the content is in orange, and the overarching cross-cutting concepts are in green. This allows the educators to take a look at a more in-depth part of what is expected of those students when they meet a performance expectation. To break down those student do pieces just a little bit more, these are the science and engineering practices. If you'll note that there are 8 of them, there are 3 particular ones that are sort of at the core of the 8. Number 2 is developing and using models. And these are conceptual models, not models of a cell part or a diagram of the rock cycle that you might be able to find in a textbook. This is finding out what students know and developing a storyline on how to increase student understanding of a concept. Number 6, which is constructing explanations and designing solutions. This is also a key component, both written and orally, that students are going to need to be able to accomplish. And then number 7, engaging in argument from evidence. To construct an explanation, students will have to engage in argument from evidence, so there will be a lot more science talk in classrooms. If those 3 are done well, then 1, 3, 4, 5, and 8 are probably going to be happening as well. A lot of teachers have been asking, well, where's the reading and writing in science? That is number 8, obtaining, evaluating, and communicating information. It hasn't gone away. In fact, it's one of our core science and engineering practices. So where do we find these standards? Well, we have a few different places. MDE has provided 2 documents, both the Michigan Science Standard document as well as a draft Michigan Educator document. I do want to show both of those to you so that you understand the difference between this Michigan MDE regular science standard that actually were adopted and the Educator document. The third place to find them is, of course, the NGSS website. This is the national website that has the original standards on there and a lot of very helpful resources on there. But let me take you to the two Michigan documents. The first document is, it still says draft or proposed standards on there, but what I want you to take a peek at is it actually only shows you the performance expectations. These could be useful for a parent document or standards-based report cards, but they're not robust enough for teachers to use in planning. So let me take you to the draft Educator document. That's the other Michigan document that's created. This one still is in draft form. I'm going to grab a second grade one so I can show you a couple of things on it and scroll through. You can kind of see that they have a lot more information. At the top, you have the performance expectations up here. Then you have your foundation boxes, what students do, the science behind it, and those cross-cutting ideas. Then at the bottom, all of the Common Core Math and ELA is linked to them already, which is a very nice benefit. Right here, I want you to notice the two Michigan MITs here. One thing Michigan did do that is slightly different than the NGSS is add a few local components to the science standards. There are a few embedded into the standards that are very Michigan specific. So you won't see all of these robust pieces on the legislative document, so if a teacher is to plan, it would probably be both easier and more beneficial to use the Educator document. So let me bring you back. These are linked as well in the Google document. So this is the legislative document with just the performance expectations. Here's the Michigan Educator draft document that I just showed you that will have those Michigan mittens in anywhere necessary. And then lastly is the NGSS website, and that again is going to be very similar to the Michigan draft document with multiple resources available for use as well. Another excellent place to use to plan. Okay, just a few basics on the standards that probably you should be aware of. The NGSS and Michigan Science Standards are essentially the same. Other than a few local or place-based science standards, they are identical, copied and pasted straight from the NGSS website into the Michigan Science draft document. The other piece that you should understand and be aware of is that engineering is a new component to these science standards. If you see an asterisk next to a standard, or if you find that set of engineering standards at the end of a grade span, those are new to science. And one thing you need to be aware of is they are not intended to be pulled out and taught separately. They are intended to be embedded into the science standards within that grade span. One thing I know that you will probably need to do as an administrator is give your staff a little bit of information. This is a short 2.5-minute video on the structure of reading a standard when you look it up. I'm not going to show the video right now, but it will be below this video as one of your resources if you'd like to take a look at it or if you need to show it to your staff. Okay, one other piece that I want you to be fully aware of is that this particular set of standards was built on progressions. What that means is vertically, it is aligned K-12. So what happens in kindergarten through 2nd grade is the foundation for what will lie ahead in 3rd through 5th, and then 6th through 8th, and 9th through 12th. But one thing we want educators to be aware of is that we do really need to be intentional about finding out what prior knowledge students have so we can fill in some of those gaps before moving on to a more challenging topic or concept that needs to be addressed. The next thing I'd like to talk to you about as an administrator is what a classroom might look like after a supported change to the Michigan Science Standards has occurred. The first shift you should see in a new science classroom is a culture and climate shift. We want to encourage teachers to take risks by trying lessons in a different way. Hopefully, the risk-taking by the teacher will then be seen in students. We want students to take risks by asking questions and maintaining that human curiosity that really encompasses science. Because we also want learning to occur, we want teachers to collect formative data on a regular basis. So they should be, formative assessments should be heavily embedded into units. We also want to have students doing and talking science. What this means is the students should be participating in those science and engineering practices, and then also very intentional science talk. This is very familiar for elementary teachers with that new shift in math, so that will carry over into science. For those teachers who are uncomfortable with that, they're going to have to create norms for conversation with intentional purpose for talking. I have linked a teaching channel video here, and I will click on it just to show you. This is an 8th grade classroom where the teacher has shifted it from teacher talk to student talk and student learning. It's approximately 9 minutes, and it's linked at the bottom of this page when you're ready to view it. Some other shifts that we're going to need to look for. One huge piece will be an instructional shift. A lesson or a unit should be grounded in what's called a phenomenon. For those who are science-minded, this may bring you back to something like a discrepant event, a phenomenon that students can't already explain with the background knowledge that they previously have. Or if you're a project-based learning person, this is a problem that needs to be solved, and we don't have a perfect answer for that particular problem right now. In order to solve this phenomenon, students are going to have to show models of their thinking, their current thinking, and then develop the models into a more robust understanding of a concept over time, instead of being told or reading the answer straight from a textbook. What that means is teachers are going to have to create lessons that create a storyline that allow that thinking to progress over time. This, again, when I talk about developing models, is not regurgitating on a poster the rock cycle or a cell made out of Jell-O, because this is not an art project, it's a conceptual development. One other thing that students are going to have to be doing is constructing an argument from evidence. So they're going to need data from lab experiences, they're going to need data from reading, they're going to be having conversations about information they're already aware of, and that brings us over here to those purposeful conversations and very intentional science talk. And then using all three of those to explain that phenomenon, students are going to be constructing explanations, both verbally and written. They'll do this at the beginning, middle, and end of a particular unit or lesson as well, so that you can see how those things change over time. Teachers need to begin using this order of operations, ABC, CBV. We want the activity to occur before the concept, so they can sort of have something that they are grounded in first, that everyone's talking equally about, and then you can introduce the concept. After the concept, you can introduce the vocabulary. The vocabulary gets hung on the concept, not vice versa, so introducing vocabulary before a unit is no longer considered good practice. So that's something that will definitely change. Teachers are going to need support as this instructional shift occurs, and some professional development as to what this might look like in their classrooms. Another piece that's going to be very beneficial for teachers are the evidence statements and equip rubrics that are available on the NGSS website. We'll bring you down to the equip rubric component right here, and you can actually click on it, and there will be a list of things that teachers should look for as they develop lessons. And if you scroll down even further on the resource page, there are evidence statements. I'm going to click on the grade 6th through 8th evidence statements, so we're kind of in the middle world here. Scroll down and you can see that there is a full list of evidence statements. I'm going to click on one of them so you can see it. And it gives you the performance expectations, your foundation boxes again. And then if you scroll down to the bottom here, it gives you a list of what is expected by the student at the end of being able to accomplish that particular performance expectation. These are similar to the companion document in the GLICs and very easily turned into rubrics that teachers could use as a checklist for whether or not students have accomplished that particular performance expectation. Okay, so again, those are beneficial resources as you get started. As we do make instructional shifts, remember both for you as well as your educators that these shifts take time. And so some very wise person told me, think marathon or Ironman, not 5K. It's going to take time and a lot of support. If teachers can support one another somehow by sharing their successes and their failures together and allowing themselves to fail, which educators aren't always very good at because we tend to be high achievers, that's a benefit as well. All right, the last thing I want to address with you prior to completing this professional development is talking a little bit about the assessment. And we're going to focus specifically on the M-STEP. So the assessment is going to contain all 3 dimensions of the Michigan Science Standards. So your disciplinary core ideas, your science and engineering practices, and your cross-cutting concepts. There has been 2 cluster prototypes of these particular assessments written already. Let me take you to those. Those are at CCSO and West Ed site. There are about 8 states as well as West Ed participating in this. I'm going to take you to the high school cluster prototype, and you're not going to be able to see all of it, but I think you can see most of it. And it will be linked again as a resource at the bottom of the page. It will take you through the research and thinking behind the cluster item that they have created. It will talk a little bit about what they've linked together and what those questions will look like. It's about 35 to 40 pages for each prototype, and so you'll want to take some time to peek at those when you get a chance. Let me bring you back to the professional development set of slides and just talk to you a little bit about what an item cluster overview for the assessment might look like. Of course, these are planning on being technology enhanced, similar to our language arts and math assessments. But if you can take a look down here, what they will do is they will what they call bundle 2 or 3 performance expectations together to create what's called an item cluster. That item cluster then will be based on one stimulus or phenomenon, which is how we should be teaching in the classroom. That stimulus might be a video, it could be an interactive lab, it could be a short reading assignment that the student must perform prior to answering those questions on that M-STEP. Once they get past the stimulus, then each of those items that are linked to that one stimulus will be testing based on this stimulus. So for instance, item number 1, I believe this one particular one is a drop-down set of menus to fill in blanks with words, and it is testing 2 of the 3 dimensions, the science and engineering practices, and the cross-cutting concept that is linked with that particular performance expectation. The next 3 items are actually testing all 3 dimensions of learning, the disciplinary core idea, science and engineering practice, and cross-cutting concept of this particular performance expectation. So please note that these are being assessed together and not separately. So teaching and assessing them separately in a classroom is not a wise decision either. All right, let's take a look at the assessment timeline here from the state of Michigan. This year in spring of 2016, the M-STEP will stay exactly the same. In 2017, we will have some pilot and crossover items only. So the pilot items will be those technology enhanced items with the stimulus and questions that follow. The crossover items, what that simply means is they're going to pull, similar to what they did with Common Core, anything that doesn't cross over GLIC and Michigan Science Standards. So if they don't work together, if there's a standard that doesn't fit with one another, then they will take it out. So you can have full confidence that if you transition to the Michigan Science Standards next fall, you should not have any issues with the M-STEP. Now, in 2018, if and only if some of those pilot items go perfectly, you will have some new test items that actually will count from the pilot in 2017. You will continue to get more pilot items and some crossover items as well in 2018. 2019, we will start to see some of those new test items from the pilot count, but there will probably also still be some of those just plain old multiple choice as well. In 2020, I believe we will end up with the full new test, and they will continue to build the test bank from the MSTEP. If you go to the MDE website and a teacher is interested, or you happen to be interested as an administrator to write some of those test or assessment items, they are looking for teachers to do that over the next few years. All right, the last thing I want to do is talk about the course progressions. If you happen to be an elementary administrator, this is probably where you can bow out and skip to the end where there's contact information if you need me. If you're a middle or high school administrator, then you'll probably want to stick with me because we have a little bit longer to go here. All right, let's start with the course model conversation. If you are unfamiliar with the Michigan Science Standards, they did not determine what should be taught in 6th through 12th grade. Instead, they're called grade spans. What that means, though, is we have to make some decisions. I talked a little bit about the fact that these are vertically aligned standards, which means we do have to be careful what's taught in 6th grade versus 8th and what's taught in 9th grade versus 11th. They did provide a few documents to help us with that decision. The first thing I want to just mention, if you do plan on purchasing a curriculum, first of all, please note that there is not a lot of curriculum out there that is fully aligned in GSS yet. But if you happen to purchase one, you want to be sure to use their course model. And what I would also ask the company is a copy of their alignment to the PEAK rubric to see if that particular curriculum is truly aligned to NGSS standards as well. All right, for those of us who are going to band-aid and create some of our own lessons and start shifting thinking a little bit, what would they have done is Michigan and NGSS have provided 2 resource documents that we can use. I'm going to take you to the Michigan Model Course Map first, and that mapping resource will bring us to some possible suggestions on what we might want to look at when we transition from our GLICs to the Michigan Science Standards. If you'll notice in middle school, well, first of all, I need to tell you that anything in orange is what is proposed by Michigan. If you go to the second page in gray, that's what we are currently doing in Michigan. So be sure you're using the right page to take a peek at where we want to head and not where we're at right now. The orange pieces are adapted models that do meet the framework or the NGSS course models in Appendix K. Notice it's 6th, 7th, and 8th grade. It really is fairly similar in most of the models. Physical science tends to go first, life science second, and earth systems third. You can mix it up a little bit. This right here is called the conceptual progression model, and I'll show it to you in just a minute. But one thing we need to be certain of is that when the students get into a 6th, 7th, or 8th grade setting, that they are matching up with the math and language arts that they can do at that particular grade level. So if the math becomes too difficult by moving things around, then we have to be a little careful with that. So if we start with middle school, the 6th, 7th, and 8th grade, I'm now going to take you, and I'll get to high school in just a minute because it's a bigger conversation. I'm going to take you to Appendix K for middle schools. I'm going to take you to the model course map, and there are 3 recommended maps or progressions for middle school. The first is considered, let me scroll down a little bit here, the conceptual progression course map for middle school. This is the recommended one by NGSS and takes into those vertical progressions. Now, the issue with this particular one is course 1 is considered the 6th grade course, 2 the 7th, and the course 3 the 8th. You'll notice just the sheer quantity in course 1 versus course 3. It's going to be really challenging for a 6th grade teacher to accomplish everything that's suggested in the conceptual progression model for middle school. So, although it's recommended, I'm not sure that it's very practical. So what they did was they created a revised course for the conceptual progression. So you still have the vertical alignment there, but you have a much more evenly balanced 6th, 7th, and 8th grade set of courses. So this is probably what will be best vertically aligned. With that said, depending on your staff and choices within your district, there is a third model called the domains model, which is very domain specific, meaning physical sciences in 6th grade, life sciences in 7th grade, and earth and space is in 8th grade. Now, I just want to make a note that these earth and space science standards are actually middle school standards. You can see the MS right here in the standard itself. The high school earth science standards may no longer be taught at the middle school level unless you have an advanced placement course progression that you are using with gifted students. So this set of standards are middle school standards. This is the first time in about almost 9 years since we've actually had a set of 8th grade standards. So that's just something to keep in mind when you're making those shifts. Okay, so really there are 3 models for a middle school course progression sequence. All right, let's talk now a little bit about the high school. This is a whole nother ballgame. One thing you want to do is take a look at the progressions in 9th through 11th grade. One thing you'll notice with most of them in the 9th grade column is that you see physical science first, or some version of physical science first. And your biology or chemistry tends to end up in 10th grade, and your 11th tends to be some sort of environmental or earth science situation. Now, this can be challenging depending on your highly qualified, certified teachers that you have working for you. So course descriptions are going to be really, really important here. The recommended model is physical science, which would actually contain both chemistry and physics. If you have specific chemistry and physics teachers, you could make these half-credit courses where they take a half of credit of physics and a half a credit of chemistry. The plus is for some of the extra pieces that may either overlap in biology and earth or need to be added so that they are there prior to biology and earth, so a vertical progression alignment can occur. Biology is in 10th grade, earth is in 11th. Remember that your DI and DX people are qualified to teach anything. Your physics and chemistry people and your biology people may have some challenges. The second progression here is actually a 4-year progression, so it's probably one you want to stay away from unless you have special education or EL students that you need to slow that process down for science. You see some other options here where we have a physics with astronomy, chemistry, and biology, geophysics class with a biochemistry class, and an environmental class here. You need to be a little bit careful with adding anything to the biology because that is the heaviest set of standards in the new Michigan Science Standards. So adding chemistry and biology together, unless you have a teacher who's really good at bundling things, could be overwhelming for a bio teacher. Michigan will be encouraging you to be slightly innovative with some of your course progressions in high school if you so choose to. You do want to keep in mind mobility rates at your particular school if you want to create an innovative way for students to reach their standards by the end of 11th grade. Remember, the Michigan Merit Curriculum component has changed, so as long as students are able to accomplish all Michigan Science Standards between 9th and 11th grade proficiently, then they have met the expectation for graduation. They no longer need to have biology, chemistry, and physics to graduate. Another thing to keep in mind, if you do create courses like are suggested down here, you will have to create a course description that will align with your teacher's certification, and that can be challenging. You also want to keep in mind the NCAA clearinghouse so that you have student athletes who are all set to head to college without any issues. All right, This is a huge conversation and probably one that needs to be thought out and taken some time on. Please let me know if I can help you with that or any other conversation as you move forward. Just be aware of those issues as you sort of think about how those courses might look in both the middle and high school levels. Okay, that brings us to the end of the video on administration awareness for the New Michigan Science Standards. If you have any questions, please don't hesitate to contact me. There is my contact information, email, and phone, as well as you can reach me on Twitter if you need to. There is a whole set of resources on the right-hand side of this that you can look at either through the Google Slides or below this particular video as needed. If you are creating some of your own lessons or teachers are creating some of their own lessons, it might be a good idea to try some of those curriculum crafter units. They are Michigan Science Standard aligned. However, please note that they are missing a phenomenon. So teachers will need to come up with a phenomenon that sort of grounds that particular unit. All right, again, please don't hesitate to contact me if I can help you with this transition at all, and good luck with your endeavor.